Hello everyone, welcome to It's All About Economics, and today's topic is one of the important measure of central tendencies, that is mode. And this is the part of a paper that is called Statistical Methods from Unit 1A. I'm Suraj Sharma. For more details, you can email me or you can text me. For more videos on economics and particularly to the idea of economics, you can subscribe my channel, or you can just like or comment the videos. So starting with the objectives, in last class we have gone through what actually arithmetic mean and median is, the calculation of mean and median, the merits and demerits of the same, and how we can locate median graphically using Excel or using manuscript or handwritten location. Now in this particular class we would be focusing on what mode is, actually the uses of mode, the calculation of mode, the merits and demerits of the same, and locating mode graphically using Excel. So what mode is and the use of it? It comes from the French word la mode, meaning fashionable. You must have heard about the fashion brand La Mode. That is the essence of this name, which comes from the word fashion. So it is the most popular or in fashion number or most often observation in a data set, around which other items of dataset cluster densely. So this is how we can have a gist of mode. It is not unique actually, meaning that there may be several modes in a dataset. So if you are having two modes in a single frequency distribution, that would be called bimodal distribution, and if you're having more than two modes in a single frequency distribution, that is called multimodal distribution. This can be applied to any data. This is the very important characteristics of mode. And for example, if you go and ask a shoe vendor that what is the average shoe size you sell, then this is actually we are talking about mode. If you want to go for a movie, and where you see that where most people are going, so that is actually mode. Choosing color of car as one of the most people are buying, and here too we are talking about mode. So what actually mode is the value which occurs most frequently in a set of observations. And if you simply put it, it is the number which is repeated most, etc., the number with the highest frequency. In the field of statistics, it is an important a tool to interpret the data in a relevant manner. And it is possible that you may have bimodal or multimodal frequency distribution. And this is what mode is. Now mode for discrete frequency distribution. If your frequency distribution is discrete, then how can you calculate mode? Simply, mode is the value of x corresponding to maximum frequency. So with this particular example, we see that these are the x values and these are the frequency of occurring these corresponding x values. We can see that here the x values are from 1 to 7, and the frequency of occurring increasing till the value reaches to 4, and that is 17. So here you can see that the maximum frequency of this distribution is 17, that is and the corresponding x value is 4 for that. So simply the value of x corresponding to the maximum frequency, that is 17, is 4. So our mode is 4 for this given frequency distribution. Now method of grouping, why we actually want this method of grouping. Let's go for this. In any one or more cases where the maximum frequency is repeated. The second thing, maximum frequency occurs in the very beginning or at the end of the distribution. or there are irregularities in the distributions. So what does it mean? What the gist is that if your frequency distribution is not regular, then the value of mode is determined by the method of grouping. Here simply identifying the maximum frequency and corresponding x value will not give you the mode. So here you would be using method of grouping if your if these three, one or the other, these three cases occur in your frequency distribution. Now, what does it mean by method of grouping? It is actually combining the frequencies in a systematic manner. What we actually do, how we actually do method of groupings and how it works. Now, simply, first of all, we'll have an example by which you can understand that how this method of grouping works actually. Now, this is the frequency distribution we have. As you can see that here we having x values from 1 to 12 and frequencies for the corresponding x values. As you can see that the frequencies are increasing for from 3 to 8 to 15, 23 for 4, 35 for 5, 40 for 6. So here you can see that 6 is having the frequency 40. And as we move ahead, we can see that the now frequencies are decreasing, but suddenly we have a value that is x, and for that the frequency is 45. That is maximum in this overall frequency distribution. So if we go with the simple identification of the of mode, that is that is the most frequently occurring value. So here the mode should be 10, but we can observe that this frequency distribution is irregular. As you can see that in the beginning or in the or particularly at the end, we are having the maximum frequency and it is somewhat irregular. So from this if you see the maximum frequency is 45, so mode should be 10, but it is not the case. Here we have to use the method of groupings. How it works, solution is this. First of all, the step one, we'll have to combine the frequency 2 by 2, and by which we get column 2. Combining the frequency 2 by 2 means that first of all we'll start with this first value. We'll combine the frequency of corresponding value of x, that is 1 and 2. So 3 plus 8, then 15 plus 23, then 35 plus 40, and so on. Step 2, we'll leave the first frequency and combine remaining frequency 2 by 2. So and by doing this we'll get column 3 in next slide. So we'll leave the first frequency, that is 3, and the corresponding x value is 1, and we'll start from here. The same method would be applied from here, like we'll add the frequencies of 2 and 3, then 4, 5, then 6, 7, and so on. So we'll add 8 plus 15, then 23 plus 35, then 40 plus 32, and so on. In step 3, we'll combine the frequency 3 by 3. As we have done it for 2 by 2, we'll do it 3 by 3, and the outcome will be in column 4. Like we'll add the corresponding frequencies of x equal to 1, 2, and 3. So 3 plus 8 plus 15, 23 plus 35 plus 40, and so on. In step 2, we'll leave the first frequency and do the same thing with the remaining frequency 3 by 3, and we'll get it in column 5. Similarly, we'll leave first two frequencies, means the corresponding frequencies of x is equal to 1 and x is equal to 2. We'll leave these two in step 6, and we'll start from here. So 15 plus 23 plus 35, then 40 plus 32 plus 28, and so on, and by this we'll get column number 6. Continuing with the same thing, if you have done with that, you will get this table. So here are the frequencies, and this is the original x values, and these are the original frequencies. And you can see I have highlighted it, the maximum frequency in the first column. In the second column, we have done the combining of frequencies 2 by 2. So 3 plus 8 is 11, 15 plus 23 is 38, 35 plus 40 is 75, and so on. Here what we have to do is just highlight the maximum frequency in each column. So we have highlighted 75 here. Similarly, in column 3, what we'll do, we'll leave the first frequency and combined the remaining 2 by 2. So 8 plus 15 is 23, 23 plus 35 is 58, and so on. And here we have highlighted the maximum frequency, that is 72. Similarly, for column 4, we have done combining the frequency 3 by 3, and in column 5 leaving the first frequency and combining the 3 by 3. So 8 plus 15 plus 23 is 46, and so on. So we have highlighted here too the maximum frequency, and in column 6 we leave first two frequencies and we'll start with frequency uh, 15 plus 23 plus 35, that is corresponding to x values 3, 4, and 5. And similarly we'll highlight here too the maximum frequency. It is very important to mention here that if you are left with unmatched frequency or values, you will leave those frequencies. So here if you see that we have combined 2 by 2, so all 12 values have come together, but when we leave first frequency, we are left with the frequency 6, that is the corresponding value x is equal to 12. So we are left with this, and we haven't did anything with this frequency. Similarly here, so what we'll have to do, first of all, highlight the maximum combined frequency, what we have already done: 45, 75 here, 72, 98, 107, 100, and see the corresponding x values for maximum combined frequencies. It means that for 45 that is 10, for 75 that is 5 and 6, for 72 that is 6 and 7, because by combining 6 and 7 we have got 72. For 98 we have 4, 5, and 6, because the corresponding frequencies of 4, 5, and 6 we got 98. Similarly for 107, that is 5, 6, and 7, and for 100 the corresponding x values are 6, 7, and 8. And with this you will have to make an analysis table with each maximum frequency or combined frequency, putting corresponding x values in front of the frequencies. Now finding the mode, the last step here. This is the earlier frequency table and this is the analysis table. So in each row we have column number 1, column 2, column 6. These are the columns. So maximum frequencies here: for column 1 that is 45, for column 2 that is 75, for column 3 that is 72, for column 4 that is 98, and so on, and the values corresponding to the maximum frequencies, as I have already shown you that for 45 that is 10, for 75 we are combining the values 5 and 6, for 72 6 and 7, and so on. And here you can see I've highlighted this number, that is most repeated one. So here the value x, that is equal to 6, is repeated maximum 1, 2, 3, 4, 5 times. So what we have to do is we just have to find the value 6 is repeated maximum number of times, and hence the value of mode is 6, not 10. So this is how we do method of groupings and we find mode accurately. So if you have any if you have irregular frequency distribution, particularly the discrete distributions, you should use finding the mode using method of groupings. Now mode for continuous frequency distribution. We'll have an example, and by that you will understand it very easily. So these are the class intervals: 0 to 10, 10 to 20, and so on, and these are the corresponding frequencies. As you can see that this is the exclusive exclusive type of table. So if you don't have exclusive type or continuous frequency distribution, then you will have to make it. So if you are having a frequency distribution that is having the classification as inclusive type, then you will have to make it exclusive first, then you will go ahead with that. Now first of all, what we'll do, we'll find the modal class, and as you can see that the maximum frequency is 28 and there is no such irregularities in this frequency distribution. Most of the values are densely clustered around this modal class. So we have found the modal class, but we for exact value of mode, we'll have to do what, we'll have to use this particular formula. So mode is actually L plus H into F1 minus F0, dividing it by 2 F1 minus F0 minus F2. And what is L here? L is the lower limit of the modal class, H is the magnitude or the class intervals, F1 is the frequency distribution of modal class, so that is 28. F0 is the frequency of the preceding class of modal 1, so that is 12, and F2 is the frequency of succeeding class of modal class respectively, so that is 20 here. So what we'll have to do, just put the values at the respective places, and as you can see here, mode is actually 40, that is the lower limit of modal class, plus 10, that is the magnitude, 0 to 10, 10 to 20, that is equal for every class interval, into 28 minus 12. 28 is the frequency of modal class, 12 is the frequency of the preceding of modal class, dividing it by 2 into 28 F1, that is this, and finally when you calculate it, you will get it as 46.67 approximately. That is your mode for this particular continuous frequency distribution. So if you are having continuous frequency distribution, you will have to just find the modal class first using the most frequent class, or the class that is having the highest frequency, and just put the values in this formula and you will get your mode. Now, merits and demerits of modes. First of all, we see the merits. It's very easy to calculate and understand, as we have seen earlier, and it is readily comprehensible. Like median mode can also be located merely by inspection, or you can locate it graphically. I'll let you know that how you will do it. It is not at all affected by extreme values, and open-ended class are not a big problem when we calculate mode. Now some demerits. Mode is actually ill-defined. What does it mean by it is not always possible to find a clearly defined mode? So in some cases we may come across distribution with two modes, and such modes are, or such distributions are called bimodal, or you can have more than two modes in a single distribution. Those are called multi-modal distributions. Second, it is not based on all observation. That is the weakness of or the demerits of mode. Third, it is not amenable to algebraic treatment or further calculations. So the best one in this is mean, which is actually which can be used for algebraic treatment or further calculation. That is arithmetic mean, but mode cannot be. Compared to arithmetic mean, mode is affected much by fluctuations in sampling, and this is one of the demerits of mode. Now we'll see how we can locate mode graphically, and for that I let you know how you can do it. First of all, you will have to have a frequency distribution, and we are using the earlier frequency distribution which we have taken in the last example. And first of all, what you will have to do is plot the histogram. So you will have to represent the given data in the form of a histogram. The height of the rectangle in the histogram is marked by frequencies. Actually, you can see that the height of this rectangle is actually corresponding to the frequency of this class. interval as shown in the graph. Now identify the highest rectangle, and you can see that is 40 to 50 modal class, and the highest frequency is 28 here. The corresponds to the model class of this series. This is the model class, as I have already mentioned. Now what you'll have to do is identify this. We have identified it. Join the top corners of the model class with the immediate next corners of the adjacent rectangles. As you can see here, the two lines must be cutting each other. These two should intersect each other, and you can see here that what you'll do, you will combine this point with the adjacent highest point, and this point of model class with the previous or preceding classes a rectangle, and where these two are actually intersecting at this point. Let's suppose this is point A, and you will have to draw a perpendicular to x-axis, and this point is actually giving you the mode. This is the point which is mode for you, and I've already mentioned and calculated it for you. That was 46.67. If you put it in a parameter, you will get it as 46.67. so here is your mode. Now we have gone through three different types of frequency measures of central tendencies, that is mean, median, and mode. And now I'll give you a gist that which can be used when. So for different types of data, you can use different types of measure of central tendency. Like for interval data, where only differences can be interpreted. For example, I'll already mention that temperature is a variable that is interval. So here mean and median, particularly skewed distributions, if you have skewed distributions, you can use median, otherwise you can use mean. In ratio variables or type of data where differences and ratios both can be interpreted, for example height, weight, etc., and where a true zero exists, you can use mean or median in case of a skewed distribution. Particularly to mode, when we use mode is actually where our type of data is nominal. And what does it mean by nominal data? It's mere a classification. You cannot order the categories here. For example, gender, type of house, mode of transportation, and here you actually use mode or the most frequent observation here. So you would be using nominal data. You would be using mode for nominal data. Particularly if you have ordinal data, for example level of education, life satisfaction on a scale or a Likert scale, then you would be using median to identify the measure of central tendency. And as you know that ordinal data are those where values can only be ordered, differences and ratios cannot be interpreted. So in case of ordinal data, you can just use median. Thank you so much for being with me. Stay healthy. Thank you so much.